welcome back with Professor Solis and Strategies for Success. So we're going to look at imaginary numbers today. So why do we learn imaginary numbers? It allows us to work with square roots of negative numbers. So the idea is that I is defined as the square root of -1. So in case we forgot, the square root of -1 equals little I. So we write it with the lowercase I, not a capital I. Now, we have 4 rules for imaginary numbers. We have I equals the square root of -1. We have I squared equals -1. We have I to the third power equals -I. And we have I to the fourth power equals a +1. So, we have these as our imaginary rules. Imaginary number rules. And then remember, in another video, we talked about the real number system. And we had rationals, we had irrational numbers, we had integers, we had whole numbers, we had natural numbers. When we put the imaginary numbers and the real numbers together, we get what we call, I'll put it right here, a complex number. So a complex number has the real part. We write it as a plus or minus bi. The a is the real part. And the bi is the imaginary part. So together we call it a complex number. Okay, a plus or minus bi. So what we want to do is we want to be able to simplify imaginary numbers. So I'm going to erase this. I was just trying to recall your memory with complex numbers and the real number system. So let's just focus just on the imaginary numbers. Okay, so if we want to simplify an imaginary number, let's say we have the square root of -3x. -36. So what I always tell students is think about separating and getting rid of that negative under the radical. So I would separate this into 2. I would separate the negative from the positive part of the number, and this would be that -1. That's that negative right there. So the square root of -1 is I. So we can replace the I with that negative. The square root of 36, if we recall from our perfect squares, you break down 36, do a factor tree. What times what gets me back to 36? Some of you might say 4 times 9. That's okay. Then we break down 4 into 2 times 2 and 9, 3 times 3. What we're doing is we're looking for pairs. So we break our factor tree down into prime numbers. And then I have a pair of 2's and I have a pair of 3's. So what you do is you bring those pairs in front of the square root house. So we have that I that was brought out. We have a 2, a pair of 2's, a pair of 3's. And what we do is we multiply all those together and we end up with 6i. We write the coefficient in front of I. Now some of you don't need to do all the breakdown of the factor tree. Some of you are like, oh, I know the square root of 36 is 6. Then that's fine. You could go straight from here to here, and you don't have to do that because you have that in your memory bank, and that's okay. So let's think about a second one. Example 2. What if we looked at the square root of -81? So once again, separate the negative from the other number. We call the number under the radical the radicand. Now, we said the square root of -1 is your I, that's your imaginary, and the square root of 81, if you don't need to break it down with the factor tree, then most of us would say 9. But if you don't see it, you can do a factor tree down, you can do it to the right. What times what is 81? I'm hoping most of us would say 9. And right immediately you say, oh, I have a pair of 9's. So now, square root of 81 is 9, but we have to put them together by multiplying. And so the square root of -81 is 9i. So those are not too bad, but let's get it to where we have a little bit more, which means we want to look at when we have more than one imaginary number in our expression. So if we wanted to add imaginary numbers, and we had 3 plus 2i plus 5 minus 4i. So this would be our problem to add imaginary numbers. Okay, this plus sign means we're adding these. So you're looking for like terms. 3 and 5 would be 8. Once I use it, I cross it out. Then I have 2i minus 4i. So you look at 2 minus 4, that'd be a negative 2, and you keep the I. This would be adding two complex numbers, or with imaginary numbers. Combine like terms, watch your signs. All right, let's think about a subtraction one with imaginary numbers. If we subtract, we would still start off with our complex form. 7 plus 3i minus 2 plus 5i. Subtraction is where students, we tend to make the most mistakes because we forget to distribute this negative sign. So you have to distribute that negative before you do any subtracting. So I'm just going to rewrite 7 plus 3i. This would be a negative 2, negative times 2, negative times 5i. And then we drop the parentheses. And now we have addition and subtraction left. When we combine those, 7 minus 2 would be 5. 3i minus 5i would be a negative 2i. This would be subtracting these two complex numbers that have imaginary. Not too bad. All right, let's think about multiplying. If we multiply complex numbers, we can look at, if we remember the FOIL method. So let's look at 2 plus 3i times 4 minus I. So if we recall the FOIL method, I'm going to put in here in parentheses FOIL. First, 2 times 4, 8, that's your F. 2 times negative I, negative 2i, that's the outer, that's the O. The I is the inner, 3i times 4 plus 12i, that's the I. And then 3i times negative I, negative 3i squared. You treat that I like a base. That's my L. Okay, so now in order for it to be simplified, we combine like terms. The O and the I are like. I'll bring my 8 down. Negative 2i plus 12i would be positive 10i. This would be minus 3, but look, we got an I squared. If we go back, remember we had square root of negative 1 is I, and I erased the I squared equals a negative 1. So we want to replace that I squared with a negative 1. Now I have 8 plus 10i. Negative 3 times a negative 1 is a positive 3. Almost done. Now combine your last like terms. So let's move that 3 a little closer over here. We had a plus 3 because we said negative 3. We had the negative 3 times the negative 1 because we replaced that I squared out here. And so now we have 8 plus 3 is 11, plus 10i. This would be multiplying complex numbers using the FOIL method. So we have addition, subtraction, and multiplication. So those are imaginary numbers. And we have more complex, but we're just going to get our basics down right now. So if we think about it, we said earlier that the reason that we use imaginary numbers is because it expands our number system so that we can use negative numbers when we're trying to find some solutions. And we use imaginary numbers in engineering, physics, and advanced mathematics. So hopefully some of you will want to take more math later. Okay, we'll talk soon.